All right, we're on page 158. Page 158. Linear and quadratic functions and modeling. Linear functions and quadratic functions and modeling. We talked a lot about linear functions already. We talked about the 5 forms, the point slope, the slope intercept, the standard form, the double intercept form, and the general form. Is that correct? We talked about that earlier in the year. Okay, so we're not going to talk a whole lot about the linear functions, but we will mention a little of them. But let's look at a polynomial function, because we're starting to talk about polynomials. A polynomial function. Polynomial function in the form of a subscript 0, a subscript 1, and so on must be real numbers with the a of n not equaling 0. Is a polynomial of degree, function of degree n. The leading coefficient is a of n. The 0 function, f of x equals 0, is a polynomial function. It has no degree and it has no leading coefficient. So this definition is what I want you to understand here is what is a polynomial. A polynomial is when we have a non-negative integer, which means what?
It's a
Positive number, or 0. If the exponent is anything but a positive whole number, then it's not a polynomial. Okay? It's not a polynomial. Okay? So, when we're looking at a polynomial, we're looking at the exponents. All the exponents must be non-negative and must be positive. Well, not negative, positive, it's the same. Non-negative and must be not a fraction or a decimal. Okay? So let's look at the example 1. 4x to the third minus 5x minus 1/2. Look at all the exponents. 3, 1, and 0. So is this a polynomial? Yes. Look at letter B. 6x to the negative fourth plus 7. Is this a polynomial? No, because of the negative 4. H of x equals square root of 9x to the fourth plus 16x squared. Well, I can take that square root and change it to a fractional exponent. How do we change radicals to fractional exponents? Anybody remember from algebra 2?
Ooh, you do something.
You factor it.
No, we're not going to factor it. Remember, the square root can be changed to what exponent in a fraction form? 1 over 2.
Oh yeah. Yeah.
Right? Because the exponent on the inside is the numerator, index is the denominator. Alright, so is that a whole number?
No.
No, 1/2 is not a whole number, it's a fraction. So therefore, is this a polynomial?
No.
No. Letter D. 15x minus 2x to the fourth. Is that a polynomial?
No.
What's that?
Yeah.
Yes, it is a polynomial. Okay? Now, let's look at the ones that are a polynomial. Letter A was 4x to the third minus 5x minus 1/2. What's my degree?
3.
What's that?
3.
3. Alright, the degree of 3. Alright, because my highest exponent is always my degree. Letter D. What's my degree? 4. My highest exponent is always my degree. Okay, so that's our polynomial functions. Is it a polynomial? All the exponents must be positive and it must be a whole number. Can't be a fraction or a decimal. My degree of my polynomial is always my highest exponent. Whether it be in the front or in the middle or wherever. Normally it's in the front, but if it's not, make sure you get the highest exponent for my degree. Alright, let's look at
So D is not a polynomial, right?
D is not a polynomial, no. Look on page 169. Page 169. Number 1. Miss Gabby, is it a polynomial? No. Why? Okay, number 2. Reagan, is it a polynomial? Yes. What is its degree? It's the one degree. What is its leading coefficient? I'm going to take the leading coefficient. It's going to be the number in front of the highest exponent
Be 2.
number. So my leading coefficient is 2. Number 3, is it a polynomial, Benny?
Which page are we on?
169.
So what was the degree?
Degree was 1.
Cause it's, what was the whole leading coefficient?
The number in front of that variable would be the leading coefficient. The 2.
Basically, whatever's in front of the x.
Number 3,
Yes.
is a polynomial. What's my degree? 5. What's my leading coefficient? Leading coefficient. No, just the coefficient. Just 2. So it's going to be in front of my highest degree term. Alright, whatever the number is in front of my highest degree term is my leading coefficient. So in this case it is 2. Number 4. Polynomial? Yes or no? Isaiah?
No.
I gave you the tricky one.
It's yes.
Yes, it is yes. Because what is my exponent here?
1.
No. Otherwise you would see an x to the 1. Here it's going to be x to the
0.
0. Alright, so that is a positive integer, or I'll take that back, non-negative integer. That's why they put it non-negative instead of positive, because 0 is not negative. So 0 could be the exponent. So yes. So therefore my degree of this polynomial is 0, and my leading coefficient is 13.
The 13 is a polynomial?
Number 4 is a polynomial, yes. So my exponent is, it's the same thing as 13 x to the 0. Is that exponent non-negative? Yes. Alright, what is x to the 0? Anything to the 0 power is? 1. 13 times 1 is? 13. So therefore f of x equals 13. So therefore, what is my degree? Well, I only have one exponent. My degree is 0. So therefore, what's my leading coefficient? What's in front of the x to the 0? 13. So that's number 4. Number 5. Jessica, is the cube root of 27x to the 3rd plus 8x to the 6th a polynomial?
Yeah.
Remember, I can take all my radicals and change to a fractional exponent. What's my fractional exponent here? 1/3. So therefore, is that a non-negative whole number? No. So therefore, is it a polynomial? No.
But you wouldn't just take out.
Nope.
Why not?
Nope.
Just why not?
Because you can't. There's 27x to the 3rd plus 8x to the 6th to the 1/3.
So
Can't simplify it anymore.
the only way that would be possible is if the 8 was a different number that went in.
No.
Well,
Not possible.
the cube root of 8 would be 2, because 2 times 2 times 2 is 8.
You can't take the cube root of a sum.
Yeah.
I'm sorry. Cannot. Alright? And again, here, the key is, what's my exponent? 1/3. Is it a non-negative whole number? No. So therefore, is it a polynomial? No. Okay? All you have to remember, can I get a non-negative whole number for an exponent and simplify? No, I can't. If it's a radical, I'm not going to be able to do it. Can't do it. Sorry, just can't do it.
So anything in a
Radical?
is not a polynomial.
Most likely not. Number 6, Blair, polynomial? Yes. Degree?
2,
And leading coefficient?
4. Wait, does that mean it's gonna be like the highest number?
Always with the highest exponent.
Like 5,
What is it?
5,
Think again, look again.
negative 5?
-5, yes. The sign always goes with the number. The sign in front always goes with the number. Amy?
It doesn't matter if like
Nope.
if the leading term is negative or
Nope.
just the exponent.
The highest degree term, the highest exponent, would be your leading term. So therefore, the coefficient in front of that would be your leading coefficient. And your exponent would be your degree.
I mean like the polynomial, like the negative, not really affect
Again, what was the definition of a polynomial? Must have a non-negative integer for an exponent. Okay? That's your definition. If it doesn't have a, if all your exponents are not non-negative, then it's not a polynomial. If they're not a integer, non-negative integer, then it's not a polynomial. Okay? Any other questions? Alright. Equations for linear functions. Function notation. What is the ordered pair for this? What is the ordered pair for this? What's my xy ordered pair? 2, 3. Alright, because inside of these parentheses is always my x, and what it equals to is my y, 2, 3. I know how to find equations of lines using slope and using point slope form. Alright, again, just like always, I say if you're finding an equation of line, I want you to find the equation of line by using point slope. So if we look at number 8, f of negative 3 equals 5, and f of 6 equals negative 2. The 2 points I'm looking at are negative 3, 5, and 6, negative 2. How do I find slope? How do I find slope? Alright, y2 minus y1 over x2 minus x1, which is, in this case is going to be, Jessica, what you were saying? I think you were saying it.
No, I was just saying form.
It's gonna be negative 2 minus 5 or over 6 minus plus 3.
Which is what? Because 7 over 9. What's my point slope form?
Y minus y1 equals m times x minus x1.
Okay. So what point will I use? Which one do I want to use?
Negative 3 and 5.
Okay. So it's y minus 5 equals times x minus x plus 3. Simplify. If I take the 5 to the other side, I'm going to take it over as what over 9? 45 over 9. 45 over 9 plus negative 21 is?
It would be 41, 44. Well, I mean 24. Sorry, my bad.
And simplify 24 over 9.
8 over 30.
So there's my equation. They don't ask what form, just put it in slope-intercept form. It's fine, if they don't specify. So that's, we talked about that before, so we won't spend a whole lot of time on that. Alright? Any questions there?
Quiz we're just take that out. Migrate.
Alright, quadratic functions. Quadratic functions are functions that have a degree of 2. That means my highest exponent is
X squared.
2, x squared. What kind of function are these?
What do you mean? They're quadratics.
Quadratics. What do they form?
Huh?
Where do they form? What's the graph look like?
Quadratic equations.
Parabola.
Parabolas.
Alright, in my parabola, I have a vertex, I have an axis of symmetry, I have an opening, we talked about these in Algebra 2 as well. My basic function for a parabola, or my standard form of a parabola, y equals a times x minus h squared plus k. Y equals a times x minus h squared plus k. My parent function is y equals x squared. So my standard form of a parabola here, what kind of transformation has happened?
For where? For the one that's on the graph, or for
Right here.
Oh, it moved h times
H units to the
right.
right.
When you went up, you
Stretched by a factor of a, and I
went up.
k units.
Yeah.
All right. So we want to be able to find vertex.
Well, the vertex is just where, would it just be 3?
All right. My vertex is always going to be HK.
Oh, hk, so it would be negative 2, 3. No, it'd just be 2, 3.
2, 3. Remember,
Because-
x is always opposite.
Yeah, 2, 3, sorry.
Axis of symmetry. Axis of symmetry is a vertical line. My vertical line is always written how? How do I write an equation for a vertical line?
Y, x equals
X equals. So therefore my axis of symmetry is
x equals 2.
x equals 2. My opening is,
It's the middle of it.
how does it open up? Where does it open up? Up or down?
Up.
Up. Alright? We could also look at end behaviors.
I forget what that means.
What is the graph doing at the extremes?
It's
On the outside?
going to infinity.
Going to infinity. So whether going to positive infinity, x going to positive infinity is going to infinity, x going to negative infinity is going to positive infinity. So my end behaviors. Now, we have learned how to get it into this form by using what process?
Translation process.
Say for instance, if I have standard form or general form of a quadratic, let's say x squared plus 2x plus 1, right? And I wanted to find the vertex, the axis of symmetry, and opening and everything. I need it in this form here.
You do, yes.
All right. So how do we learn to get it from that form to this form?
You factor, yes.
No.
Oh, you
Swearing something?
Close. Getting close. We completed
the square.
the square. All right. There's another method that we can use because I want to get it in this form, so I need to know what h is and I need to know what k is. Because my a is the same always, because I got y equals a x squared plus bx plus c is my standard form. All right. This corresponds to this. What is my a? 1.
One.
What is my b? 2. What's my c? 1. Okay.
Oh, I remember this, yeah.
Right, I can find my h by taking negative b
Over 2a.
over 2a.
Yeah. So that would just be negative 2 over 2, so it would just be 1.
Okay, so my h equals 1. I can find my k by taking c
Minus, it's hold on.
h squared. Which in this case, my c is
1.
1
So 1
minus 1 times,
2 squared, so 1 minus
no,
4.
where's my h?
Oh, 1, sorry.
1 squared, which is
1, so it's 0.
0. So therefore, what is my quadratic? Y equals, what's my a? 1 times x minus, what's my h? 1 squared plus k, which is 0. So there's my quadratic. So what's my vertex?
It would be,
We're 1, 0.
What's my axis of symmetry?
1,
X equals
x equals 1.
1. What's my end behavior?
Infinity.
Plus infinity.
Positive infinity, yes. Okay, so let's look at another one. These would be good to memorize. That's good. Okay. So I want to put it back into vertex form. So this is standard form here of a parabola. My vertex form is y equals a times x minus h squared plus k. This is vertex form. So if you see the terminology, when you see vertex form, that's what they're looking for. They're looking for standard form, that's what they have there. Alright? So standard, vertex, standard vertex. Here's how we can change. Alright? So here, we're going to rearrange it. So therefore I want to put it in vertex form. What's my A?
-1.
-1. So what's my H? What is my H?
It would be -8 over 2.
And that'd be 8 over.
It would be -8 over -2, so then it would be 4, because it's always -b over 2a.
Correct. So it would be what?
So it would be 4.
4 squared. And what is my K?
It would be c minus ah squared, so that would be 3 minus -1 times 4 squared, so that would be 3 plus 16, so it would be 19.
So remember, if we did completing the square, let's review that just for a second. You don't have to do it that way, but I just want to show you that it does work the same. Take out the negative. Oops. We take the middle term, divide by 2, square it, and add. See, I'm on the same side, I'm going to end up subtracting. Oops. Oops, I'm sorry, I've subtracted 16, so I'm going to end up adding. It's negative x minus 4 squared plus, oops, it should be 16. I'm going to do it too fast. So I get the same thing. So completing the square in this method here gets you the same result. If you remember these two formulas, this is faster to get it in vertex form. This case here, what's my vertex?
The vertex is 419.
419.
The axis of symmetry is x equals 4. The end behavior is positive infinity.
Think about it.
Oh,
Where's the
no,
opening?
it's not. It's negative infinity because it's flipped over.
Correct. So the opening's one down.
Yeah.
Okay? Questions so far?
No.
I got good markers here, but anyways.
substitute the equation if you give it to us.
Alright, so here we have the vertex is one at 1, 2, and it passes through a point 5, 8. 5, 8. I want you to find the equation of the parabola in standard form, or vertex form. Vertex form, not standard form.
Well,
Alright, so my vertex form is,
y e
Gary, is there a black marker there someplace?
Yeah.
Thank you. Ah, there we go. Y equals A times x minus h squared plus k. Alright, so what information have they given us?
they gave us the vertex, so you have h and k. So it would be ax minus 1 and then plus 2.
Alright, what other information did they give us?
They give us a point so we can find the slope. So
Not the slope, because this really don't have a slope.
The points you can plug in.
Point that we can plug in. So they give us an x and a y. So we plug it into 8, a times, oops,
5 minus 1.
5 minus 1 squared. So now all we need to do is find my
a.
a.
So it would be 8 equals 16 plus 2, well a times 16 plus 2. So then you have to subtract 2, so then you get 6 equals 16a. So then you divide by 16, and you get 3/8.
So y equals 3/8 times x minus 1 squared plus 2. So therefore, what is my vertex? 1, 2.
1, 2,
X is the symmetry.
2, I mean 1.
X equals 1. And is this a thin or wide parabola?
Isn't it
Thin.
wide?
No, it's wide.
Because you go up 3 then over 8. So it'd be
Well,
wide.
well, you can't really look at it that way.
Yeah.
Just that if A is below, A is less than 1, it's a fat parabola. If A is greater than 1, it's a thin parabola. Because again, this tells us stretching or compressing, right?
Mhm.
So if I have a number less than 1, I compress by 3/8. So that makes those arms go out wider. If I was stretching by a factor of 5, that makes those arms go up more taller.
Yeah.
So I'm actually getting fatter. No reflection on myself there.
So is that whole, is it that thing where like inside the parentheses is always opposite?
Yeah, anything we do to the x is always opposite. Okay? Yeah, let's see, what else we got here? Good stuff, good stuff. Alright, let's look at linear correlations. We haven't done it for a while, but we have done regression and stat plots on our calculator. And a lot of times when we put points on a stat plot, we get a bunch of points. And those points will relate to a particular function. They relate to a linear function, a line, if those points almost form a straight line. So we have 4 types of correlation. We have a strong positive. We have a weak positive, strong negative, a weak negative, or no correlation. Alright, so what am I talking about? I'm talking about all these points. And if I go too far, I get out. If I get all these points here, and that's my stat plot. Alright, those points are all over the place. It doesn't even look like a line. So there's no correlation. There's no linear correlation here. But if I take these points and we have an oval that could be a line, then we have a weak correlation.
So is
If
this,
it's going up to the right, it's positive. If it goes up to the left, it's negative. Then if I have a very narrow oval around the points, then it's a strong positive correlation. So negative is going up to the left, positive is going up to the right. So when I look on page 169, number 45. Number 45, is that a very narrow oval or a wider oval?
A narrow.
Narrow oval. So that would be a
Strong.
strong, and it's going up to the right, so it would be a strong positive. If I look at 46, all right, is that a narrow oval or a wider oval?
It's wider than the other one.
It's wider than the other one, but it's still fairly narrow.
Yeah.
All right, so we'll see the difference in just a second. So that would be a strong
Negative.
negative. So when we flip over the page on page 47, all right, now when we put the oval there,
It's fatter.
it's fatter, so that would be a
Weak.
weak positive. And number 48,
Would that be a weak positive or a weak negative?
Which
No
one, 47?
correlation. No correlation, no.
48 would be no correlation because it doesn't make an oval at all. It's more of a circle. So that's our linear correlation. Okay? Yeah, let's see. Let's look at number 50. All right, life expectancy. The table 2.5 shows the average number of additional years a U.S. citizen is expected to live for various ages. And how many more years I got left? Oh man, I got too many. No, just kidding. We want to make a scatter plot. All right, so we're going to take our calculator. So get your calculators out and plug these numbers in. We're going to use the actual age as our x value, and I use our life expectancy, the remaining years left. So we're going to do it a stat. All right. And we should have our table. We're going to enter the 10, 20, 30, 40, 50, 60, 70. And we're going to enter 68.5, 58.8, 49.3, 39.9, 30.9, 22.5, and 15.1. Number 50. What does my window need to be here? What does my window need to be here to get all these points in my window?
70 to 70?
No.
Disappointing.
And again, do I see any negative numbers? No. So I don't even need negative numbers in my window. So where would I start the window? I would probably start it at on my x. Start at where? 0. And I take my x and end it where? I want to take it 70 because that's going to be right on the edge of the window, so I may not see the point very well.
75.
So I can go 75. I can go 80. In my y, where would I start my y? 0. And when would I end my y?
70.
70. Okay?
I'm confused, how are we plotting these?
You take in your stat, go into stat, edit.
Pushing second?
No, just go to stat. Should have edit.
Stat? I'm confused what stat is.
STAT. Should be a button that says stat.
Yeah.
Push that. You should have some options. The first option should be edit.
Okay, got it.
You should bring up your table.
Yeah.
I don't see anything.
You change your window.
Yeah.
All right. Then go to second stat plot and turn your stat plot on.
Against that plot.
Oh.
How you turn it on?
Press enter. You should have the cursor on or off. Make sure it's on.
Second step.
Got it. Yay.
Stat plot.
1, 2, 3, 4,
Y
5,
equals
6,
second stat.
7.
What the Windows 7?
You get this.
Yeah, I go to 0 to,
I'm trying to make it
again, look at your points that you're,
Yeah, they're all positive.
so 0 to 80, I always let go, or something like that. Alright, you're good.
I could make my window smaller.
Alright, you may have another graph there, but you're just looking for the points. Alright, see Blair, she has a good stat plot there. Alright, here's good.
Got him.
Here's good. Yep. Alright, what's the correlation?
It's strong.
Strong, which direction?
Negative.
Strong negative. Alright, now let's find the linear equation that best fits this line. Okay, so you go into stat, calc. Alright, you go look for the linear regression. Number 4,
Yeah.
enter. Should have L1, L2. So you're gonna go down to where it says store regression equation.
Okay.
Go to variance, VARS.
Wait. Yeah. Okay.
Alright, go over to Y variance,
What?
Yeah.
function,
Yeah.
select Y1,
Mm-hmm.
enter, calculate.
Calculate.
No, does it go down, go down to calculate.
This is what I.
Right here? Or
No, go to,
Wow.
go your cursor down to calculate.
This is right.
Alright, enter.
I don't know what it is.
Alright, so it should give you a linear equation.
Yeah. A equals negative 2.25880952338 and B equals 44.6833333333333.
Those are not the numbers
That's
that
not
I
the
got.
numbers I got.
That's not the numbers I got.
That's the numbers I got. What'd you get?
0.897 and 76.6.
Just,
Yeah,
Yeah,
there.
that's
Oh, I put in the wrong numbers.
Alright, what are the numbers? Last time I listened to Isaiah, no, just kidding.
I skipped 20.
76.
A equals what?
A equals negative 0.897.
Let me write it down.
Oh my
And B is 76.6.
Wow, close enough. I just accidentally skipped a number. It's fine.
So,
Alright.
How'd you do that?
So there's your linear equation. If you go to graph,
Shane.
you should see a line that goes through the points.
Yeah.
Can you repeat
Best fit.
this step?
So what you got?
Alright, go to graph.
Looks like it.
Yeah, hit graph though.
Yep, very good.
I don't know what I did.
So it should go through all the points.
You hit graph.
Alright, so now this is what I want you to do.
Line go graph.
Alright? For this data that we have here, tells us the life expectancy after your age. So now I want you to go to second calc, go to value, plug in your age. What's your answer?
Wait, where were we on?
Go into second calc, value, plug in your age. So how many more years you got left, Reagan?
Is it the Y?
Is the Y?
61.3.
So you got 61 more years left to live.
Yeah.
Alright.
Wait,
Now go to second calc,
okay.
value, and plug in my age. 25. No, 58.
What do you mean by go to value?
24.
I only got 24 more years left?
24 and a half.
Oh my goodness.
No, 0.6.
That's-
You're fine.
That's too early.
You got 24.6.
24.6?
Yeah.
My
How do you
wife
go
would
to
love that.
value?
Yeah, like second count.
Second calc.
I did that.
And
You
then
should
it's
see
value,
value.
so you hit enter.
Enter just goes back to the graph.
Should be a cursor. It should say X equals cursor.
Yeah, okay.
Plug in your age.
Wait, what?
Plug in your age.
Just type it in.
How many more do you
Just
have
type
to
it.
get, Blair?
No, I just don't.
How much?
I don't remember.
Very good.
Okay, look, Isaiah.
Alright, we'll look at some more of these tomorrow.
I pushed
Have a good evening.